Good evening, Dharni, Saran, Nasir, Tanishka, Keshika, Shiva Shakti. Good evening, Dharni, Saran. Sound is there. Okay, fine. Abhirami, good evening, everyone. Okay. Good evening, beta. Now we will start the class. Here today we are going to understand first, already we have finished all this part. Now we are going towards our main content. This sections already we have finished. Already we have finished all these sections. Yes, yesterday we were talking about this point. We have finished this section. Okay, we were in solenoid. So before understanding solenoid, we are going to understand another one that is exactly called as clock face rule. Okay, so here most important point, clock face rule. This rule is called as clock face rule. What this rule is called as? Clock face rule. What this rule is exactly called as? Clock face rule. Good evening Mustafa, good evening Kamya, good evening Tawfiq, Abhirami, good evening. Clock face rule, beta. One time I am repeating, this rule is exactly called as clock face rule. Clock face rule. Clock face rule. What does this clock face rule means? Now you have to understand one very important thing here, like clock face rule. Yes, beta, this rule is exactly called as clock face rule. Now what does this rule is about is कि when a wire which is exactly conducting current or a conducting wire, okay, will have the flow of current in clockwise direction. I am repeating, when a current carrying wire, Tanishka, everyone listen to this one very nicely, beta. Ki when a wire is there, circular wire is there, and the direction of flow of current is clockwise. You see, this is the direction of clock now, like after 12 o'clock, 3 o'clock, then 6 o'clock, then 9 o'clock. So that is what? The flow of current in clockwise direction will be there. Then you see the arrow, the arrow is exactly looking like what? S. So we have to understand one very important point, that ki when a loop or a circular loop or a wire, circular wire, when it will conduct current and the flow of the current will be in clockwise direction, then the magnetic field, that is, it will act like a disc, magnetic disc. This loop will act like a magnetic disc. The direction of the flow of current is clockwise, so this face will act as south pole. You know what? The loop will be there now. The wire loop will be there. The wire loop will again generate polarity. Polarity means कि one face of the clock, one face of the loop will act as a south pole and the opposite face will act as a north pole. This is a very, very important point. You must remember. One more time I am explaining this one. Good evening everyone. One more time, those who joined right now, I am just explaining it one more time. This rule is called as clock face rule. Now what this rule is, कि if we are taking a wire, understand nicely this one, if you are taking a circular wire, okay, now the flow of the current in the wire is clockwise. Okay, now this wire will act as a magnet, disc magnet. Okay, like this shape magnet it will act. I didn't saw your message, Ajay. Good evening, beta. I didn't saw your message. I have to check, Ajay. After class, I'll check, beta. I came very late today, beta. I came very late. After that, I had some work. I was finishing my work. Okay, and then I started class, beta. I'll see message. I might have opened and not checked, but 100% Ajay, after class I am going to check, beta. So now this will be exactly acting as a loop. Now this wire is exactly acting, what this is exactly the loop. Now in this loop the flow of the current is in clockwise direction. So if the flow of the current is in clockwise direction, that means this face, this face of the loop will act as a south pole. Okay, then if this face of the loop will act as a south pole, then what will happen to the opposite face? So if the front face, just understand this one, if this is exactly a loop and the current is exactly moving in clockwise direction and the current is moving in clockwise direction, then beta this face, the front face of this bangle or the loop will act as a south pole. Then what will happen to the opposite face? Can anybody tell me what polarity will be generated in the opposite face? Who can answer this question? If the front face is having clockwise direction of current and it is having south pole, then what will be the opposite face? Absolute correct answer, Ajay. The opposite face will have north pole. I hope you might have understood. Yes, Abhirami, this is a very important point, beta, that a loop which is exactly carrying current and the current will flow in clockwise direction, then that face will have, it will act as a magnet and it will be magnetic disk, it will act like a magnetic disk. This face will have a south pole, then opposite to this face will become north pole. Then opposite to this face will become north pole. So that means it will act as a complete magnet, beta. It will act as a complete magnet. You see the thickness of this loop. So one face of the loop will act as south pole, then another face of the loop will act as north pole. So it is totally dependent upon, very good beta, it is totally dependent upon one very important factor, and that is the direction of the flow of the current. The direction of the flow of the current. In the same way, if we are exactly going to allow the loop to have current in anti-clockwise direction, if the flow of the current is in anti-clockwise direction, then it will have north pole. It will have north pole. You see this direction, so it is exactly coming as north, N. So it is coming as north pole. So if the flow of the current, now again another point I am asking, if the flow of the current in a loop will be, this face is coming north pole, means it acts as a polarity, so it is having a polarity, north pole in one face. So now the current is moving in opposite direction, then if the current will move in opposite direction, then one face will be having north pole, then what will be the other face, beta? Come on, quickly answer. What will be the other face? What will be the other face? What polarity it will generate in the other face? Absolute anti-clockwise up north. Absolutely correct, Ajay. Kavya, absolutely correct, beta. Keshika, Abhirami, Nasir, Mustafa, Shiva Shakti. The answer correct. The correct answer is exactly Dharani, Mustafa, everyone, the answer is absolutely correct, beta. It will generate south pole. It will generate south pole. So I hope my children might have understood polarity, beta. Now you have understood polarity. Now this is also only called as clock phase rule. This is only called as clock phase rule. Now we are going to understand magnetic field due to a current in a long solenoid. Now we are not going to understand this one by this part of view. We are going to understand in our own way. So now we have understood that a solenoid will be a wire which is exactly in the form of this circular coils. Okay, now we will do everything in our own without help of book. And we are exactly going to try and understand whatever property we have understand. Based on that property, we will be trying to understand the nature of the solenoid. Okay, so yes. So south pole, north pole, Tanishka, understood na beta? Absolutely correct answer, Tanishka. So now look here. So most important thing is कि when north pole, so you have to see the flow of the current in the solenoid, beta. Now flow of the current in the solenoid, there are 2-3 important points. One by one I will discuss all the points. First you see the flow of direction is from here. Now in this part it is moving clockwise or anti-clockwise. You have to keep on answering my question. So here, is it coming clockwise or anti-clockwise, beta? The current will be moving like this. So what direction you are feeling here is coming? What direction you are feeling here is coming? and after checking the direction, you are going to tell me where I should write South Pole and where I should write North Pole. Clockwise. Awesome. Very good. Super. Everyone is absolutely correct. No mistake here. Clockwise. All of you are giving the answer absolutely correct. It is coming clockwise, because if one loop I will take, then it is coming like this. So arrow is coming like this. So it's a clockwise direction. Now if it is clockwise, then which pole I should write here? Then 100% it will generate polarity. Then which pole I should write here? If it is clockwise, then which pole I should write here? If it is, yes, absolute Abhirami, absolute Kavya Nasir. What answer is going to come here? It is going to come as South Pole. So if this face is coming South Pole, then opposite one will be exactly having what? Opposite to this north, 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 north. So here it is coming as North Pole. Here it is coming as North Pole. Very good. Super, Rashmi. So if it is containing here North Pole, beta, and this coil is exactly having South Pole here, then how the magnetic lines of force will behave? Now you have to understand that, since if somebody will be asking you what could be the magnetic lines of force in a current, when a current is moving in a solenoid, then your answer will be, since in the solenoid the direction of flow of current is same. Direction of flow of current is same. You have to understand that the direction of flow of current in the solenoid is same. So the magnetic field generated around the solenoid will add up or sum up and will make a single closed curves. They will make single closed curve. What they will make? They will make single closed curve. So why they are making single closed curve? Because whatever magnetic lines have been generated around each coil, they will add up because the direction of flow of current is same. So magnetic field generated around each coil will sum up and give up a total closed curves. Total closed curve. I am going to explain again, beta. Beta, solenoid, Tanishka, beta, we will take a copper wire. Okay, sir, Tanishka, like imagine, beta, one wire I have taken, and this wire, copper, insulated copper wire I will take, and beta, look here, insulated copper wire I will take, and that copper wire, na beta, if I will turn, like this copper wire, if I am going to take, wait me, I will give you, because many wires I am having. So if this copper wire means, understand, beta, insulated copper wire, if I will keep on turning the copper wire, then it will make this circular turns are coming, na beta. These circular turns are exactly called as solenoid, beta. So this wire is there. I hope you can see the wire. Black wire is there. So this will make a solenoid, beta. The round turns of the coil, na, that will be making a solenoid. Okay. So you take a wire and then you rotate the wire, beta, and allow the current to pass through the wire, beta. Then it will be making a solenoid. What it will be? Okay, no problem, beta. I am going to explain. I have explained this one, beta. Solenoid is just like a spring. Yes, you can take it as a spring also. Now understood, beta? Tanishka understood? Tanishka understood this point, beta, that you take a wire and rotate the wire. Okay, so it will be exactly making a solenoid. Now understood, na, Tanishka? Yes, it is acting as a bar magnet. Absolutely correct, Ajay. It is acting. Understood, na, Tanishka? Now look here, beta. One wire is there in your home, na, beta. If the wire will get converted into circular one, na, then current will flow in the circular wire also. But beta, it will do a very what you call spatial work. What work will do? Now again I am explaining this point, that the current will flow in each wire, beta. But you see the direction of flow of current, arrow down, the direction of flow of current every time is coming arrow down, na. So that means all the current is moving clockwise direction. So what will happen, beta? The magnetic field generated around each coil, means one single coil, na. So around it magnetic field will generate. Now around it magnetic field will generate. So these magnetic field, na, they will add up like this. Magnetic field generated here M1, magnetic field generated here M2, magnetic field generated here M3, magnetic field generated here M4. So all these magnetic field generated, small magnetic field generated will add up, and then they will form a very big closed curve like this. Understood, beta? Yes, all the small will add up, and beta, after adding up it will become a total one closed curve will be forming. Now if you will suspend it freely now, it will act like a bar magnet which will have a north pole and a south pole. But here one advantage is having. What is the extra advantage of this solenoid over a bar magnet? Because you will be asking that, aunty, what is the need of this one, aunty? This much coiling we will do, we will allow current to pass through it. Then what is the need of it, aunty? We can use bar magnet directly. Then the answer here is, it is always advantageous than a bar magnet. In the bar magnet, the magnetic strength is fixed. Means how much the strength of the magnet is there, you cannot change the magnet strength. But this magnetic field strength you can change. How you can change? By changing the number of turns. So magnetic field is directly proportional to. So larger the number of turns. If more number of turns will be there, stronger the magnetic field around it. Stronger the magnetic field. But is the strength of the magnetic field maximum around or inside? So here the answer is, yesterday when we were doing the loop, in that we have learned that the magnetic field strength will be maximum in the center. So here beta, inside the magnetic field strength will become very high. So if we want to make a very strong magnet, what we will do, we will increase the number of turns. So we took a wire and we start rotating it beta. So if we will increase the number of turns, that much strong magnet we will get. Yes beta, you can increase the number of coils. Absolutely correct, Rashmi. Yes, you can change the magnetic intensity, Humaira. So it will be, we can change the magnetic strength as Kamya to generate more magnetic field. Absolutely correct. To generate more magnet, here we can increase the number of coils. Absolute, all of you, all will add up. Absolutely correct. Abhirami, Tanishka understood, super beta. So you can add up. So what Ajay has done, it is acting as a bar magnet. Ajay, your point is absolutely correct. More loops, stronger magnetic field. Absolute, Abhi. So more loop, stronger magnetic field. This is the first point. Second important point is beta, that means number of turn is directly proportional to magnetic field. Number of turn in the coil will be directly proportional to magnetic field. More number of turns, more magnetic field generated, more strong magnetic field generated. But where the magnetic field generated will be there? Inside the coil, the magnetic field strength or the magnetic field will be very, very strong beta. Inside, the magnetic field will be very, very strong. Very good, correct Abhirami. Inside, the magnetic field will be very, very strong. Now, you have to understand another important point, because CBSE will ask this question, that where will be the magnetic field stronger? Then you will have to say that since the magnetic lines inside the coil are very, very near to each other and they are moving parallel, so the magnetic field strength is uniform inside the coil. Means it is uniformly distributed. Outside it is not uniformly distributed beta, but inside, in this small region, you imagine all line threads are there and very nicely they are packaged and they are uniformly distributed inside the coil. So strength will be more inside the coil because the lines are parallel to each other. So there is a uniform distribution of magnetic field, and the strong magnetic field will be uniformly distributed inside the coil. Where it will be? Inside. Weaker the magnetic field. Absolutely correct, Mustafa. Yes, Rashmi, I am going to teach magnetism again, beta. Magnetism special, some questions are there. I am going to discuss first. After magnetism, this chapter I have to start carbonates compound. In between, I will give revisions also. Now look here. So here, I hope everybody understood this point, beta, that inside the magnetic field is uniform. If somebody will be asking you where the magnetic field is uniform, then you are going to say that inside the magnetic field is stronger and uniform, because the magnetic lines of force are parallel to each other inside the loop, are parallel to each other inside the loop, are parallel to each other inside the loop. I hope this point everybody understood. Understood everyone this point? Understood this one? Till here everybody understood? Till here everybody understood? Yes, Kamya. Super, beta. Everyone understood, my children? Understood this point? Come on, quickly tell me. You understood, beta? Whatever point I discussed, understood? Super, super. So now here, till this much we have understood. First thing we understood that number of turns if we will increase. Where is Tawfiq today? Tawfiq, you didn't say good evening to auntie today. So now look here. The number of turns, Srivatsan, the number of turns if you will increase, that means what, beta? The magnetic field generated will be more strong, then current supply if you will increase. Another important point is, if you will increase the amount of current flowing in the circuit, then too you will increase the magnetic field. So one thing is number of turns, and second is amount of current. So number of turns and amount of current. Yes, beta, here inside it will be uniformly distributed, Humaira. Inside it is uniformly distributed. Kamya, understood, beta? Any doubt is there? V Kavya, doubt is there, beta? Okay, very good. Now look here, beta. Look here. So number of turns and amount of current. V Kavya, understood this point, beta? Any doubt is there? Come on, quickly ask. Don't leave any point, beta. Okay, so the nature of, okay, beta, if any doubt will be there, quickly ask. Now, nature of core material. Ajay, anyone explain this one? Nature of core material. Used in making solenoid. What does this mean, beta? Nature of core material used in making solenoid. Nature of core material. Yes, Humaira, strength will be, I told you na Humaira, here it is acting as a bar magnet. This is again acting, this solenoid is acting as a bar magnet. This solenoid is acting as a bar magnet, beta. So it will have strength more at the poles. But we are checking the uniform, highest strength, the highest strength or the highest intensity of magnetic. So magnetic field intensity will be more, or a strong magnet field will be there inside. Okay, so now we are using, because we are going to talk towards electromagnet. So we are going towards another topic called electromagnet. That's why rather than talking about pole, we are talking about the internal region. So what will be the strength? So that's why we are using. Very good, very good. You all are going towards one point. Its strength will be more. Yes, strength will be more, Humaira. But here the most important point we are talking about is maximum. Maximum inside, because we are going to use the core material inside the solenoid. Just 1 minute, I will explain this point, beta. Now I use the word nature of core material used in making solenoid. Nature of core material used in making solenoid means what? Let me see who can answer this question. Nature of core material used in making solenoid. Nature of core material used in making solenoid. Some are telling soft iron rod. Very good. Nature of core material used in making solenoid. Now beta, here one very important point we are going to discuss, and that is this one. So let me show you one picture. After that you will decide. So this point I think I should show you this one. Then only you will decide. So one soft iron core is there. For discussing this third point na beta, I took a soft iron core, and in that coils, that is the what you call that insulated copper wire is turned. Now see this picture nicely and then answer the question. I'm not talking about copper wire now. I'm not at all talking about copper wire. I'm talking about something else, beta. I'm talking about something else, and Humaira, your answer is here. You were talking about now that it is acting like a bar magnet, then where will be the strength more? So it will be poles, definitely strength will be more. But here, most important thing, soft iron. Yes, yes, yes. Can you repeat the question again? Beta, the question is, it is the nature of core material used in making. I am repeating the part, nature of core material used in making solenoid. Nature of core material used in making solenoid. Till here, all of you understood the partial part of it. Now, everyone gave correct answer is iron, iron, iron. So, you know that something is connected to iron. So, now I am going to ferromagnetic materials. Absolute beta, they are exactly soft iron. Now I am going to explain this one. Tanishka, soft iron is correct answer beta. Everyone understand what does this point means. Now one point is कि when you will take, just see me what I am doing. This is a wire. Okay. Now I am turning this wire. Imagine that this pen is nothing but a soft iron. Okay. This pen is nothing but a soft iron. Now I am coiling this soft iron with a copper wire. I am coiling the soft iron with a copper wire. Now it will act as a magnet. It will act as the moment current will flow through it. It will act as a magnet. It will have a north pole and south pole. Yes or no? Yes or no? So why it will act as a magnet? Because magnetic field will be generated around it. Because this wire is there na, this solenoid will allow current to pass through it. These wires and this solenoid will allow current to pass through it. So if current will pass through this wire, then inside magnetic field will be generated, around magnetic field will be generated. Listen to me very nicely. Inside magnetic field will be generated, inside the coil magnetic field will be generated, and outside also. But I told one thing to you, that inside the magnetic field will be strong. So here I got a very strong magnet. I got a strong magnet. Now beta, what type of magnet will be, what type of core material, means what type of this material I am using, that will also decide the strength of the magnetic field or how much strong the magnet will be. If I am going to take a soft iron, then it will give strong magnetism. Understood? Soft iron material, if I will take inside the solenoid, then this will be exactly having strong magnetism. This will be exactly having what beta? Strong magnetism. And this is the third point, that nature of core material. This is the core. Around this only coil you are going to rotate. So this soft iron is the core material beta. This soft iron is what? If soft iron is the core one and this soft iron rod is the core, around it you are coiling the wire. So if you will coil the wire, inside magnetic field will be generated, and we know nicely the magnetic field will be parallel to each other. So 100% the magnetic field generated will start making this iron core as magnet. So now till the current will pass in this wire, listen to me nicely, till the current will pass through this wire, this soft iron core will act as a magnet. But the moment you will stop the connection of current, this will become again soft iron core, no magnetic property left inside it. But if another materials we will take, like take for example steel. If you will take steel inside and then allow current to pass through this coil, then the steel, after stopping the flow of current, the steel will not lose its magnetism. The steel will become magnet. But if soft iron core you will take, the time the current will flow, it will become a strong magnet. But the moment you will stop the flow of current, it will again become a soft iron rod and it will not have any magnetic property. So it will lose all its magnetic property. It will lose all its magnetic property. But did you heard it very nicely, or should I have to repeat this point? I am ready to repeat, but I want my children to write this point very nicely. I want you all to understand this one. I am ready to explain 10 times, but I want the best answer from you all. So just tell me this one you have understood or not. Tell me this one you have understood. Temporary magnet. Yes, Kamya, you have understood. This point is absolute correct. It will be exactly acting as a temporary magnet. Super beta. Kamya, absolute correct answer. It will act as a temporary magnet. Correct answer you have used. So which one act as a temporary magnet and which material will become a permanent magnet? Let's see who will answer this. Yes, Madhu, I am going to repeat this one, beta. Now look here, I am going to repeat this one from the same point what I have taken. I told Madhu that this is a soft iron rod. Okay. Now this beta, through this, I am allowing this copper wire to coil it. Okay, so now what happened beta? The current will pass through this wire. The moment the current will pass through this wire beta, now this iron rod will act as a magnet. It will have a north pole, it will have a south pole. It will work like a magnet. And if you will increase the number of turns, then it will become more strong magnet. If you will further increase the number of turns, it will become more stronger magnet. But beta, if you will increase the amount of current in the wire, then also its magnetic field will increase, its magnetism will increase. Understood? And another thing is that how much strong magnet will be made, it also depend upon this soft iron rod. If this soft iron rod we are taking inside as core material, it is called as core material beta because coil will be around it. Since coil is around it, Madhu, that's why it is called as core material. Since coil is around it, absolutely correct Shiva, absolutely correct. Usmani, iron is super, super. I think everyone started answering. Iron as temporary and steel as permanent. Absolute, you have started answering. The material beta, the material, iron temporary, steel permanent. Absolutely beta. The reason behind it, iron will lose all its magnetic property, but steel is an alloy. Steel is exactly will never be able to lose all its property. Iron will be pure, it will be exactly losing its property, but steel as an alloy will not be able to lose all its property, and steel will act as a magnet. Understood? So I hope Madhu understood na beta. So if you will increase the number of turns, Madhu, then that time beta what will happen? The current, magnetic field will increase, the amount of current in the wire if you will increase, magnetic field will increase, and beta the rod, what material you are using so that it will be coiling around it, that material also decides the magnetic field. So here this one, soft iron rod, soft iron core or soft iron rod will be exactly helping in strong magnetism. Okay, but the benefit of this is when you will disconnect the supply of current, then it will again become a soft iron. Okay, soft iron core, it will not have any magnetic property. But the moment you will take steel, now look here, last class I think someone was asking, so I have just taken this picture for explanation. The moment you will take steel, what will happen beta? After the supply of current will be stopped, it will again act as a magnet. Absolutely correct answer. It will again act as a magnet. I hope you might have understood this point. Come on, quickly tell me till here, till this much point we have understood. So magnitude of current in the solenoid we have understood 2 points, and third one is this one, the number of turns, then current, and the third nature of core material. But third will be, yes, number of turns, then magnetic field increases. Correct, Madhu. So and current also beta. So nature of core material. So 3 points were important for solenoid. We discussed all the 3 points. First, turns. Second, current. Third, material. Turn, current, material. That is the core material. And which type of core material we are going to use? We are going to use soft iron. Okay, we are going to use soft iron. Now we are going towards another concept. Yes, now we are going to understand another concept. It is called as electromagnet. How to make an electromagnet and what is the use of electromagnet. How to make an electromagnet and what is the use of electromagnet. How to make an electromagnet? Till here we have understood this point, beta. Now can you tell me how to make an electromagnet? You will say, auntie, you to discussed everything and now you are again asking how to make an electromagnet. Electromagnet is here only, auntie. This is the electromagnet. When soft iron core you will take and you will allow coils to rotate, or you will allow wire to rotate around it, then it will make an electromagnet. This is exactly the electromagnet. This is what? This is the electromagnet. This is what, beta? This is the electromagnet. I hope you might have understood, beta. This is the electromagnet. So around Madhu understand, Tanishka understood this point, beta. When a rod you are taking and when you will allow the wire to coil around it, then that will and allow current to pass through it, then this will act as electromagnet. Means electricity is passing, because of that it act as magnet. So this is called as electromagnet. Till here everybody? Correct only, absolutely correct, beta. The magnet formed by iron is called electromagnet. The magnet formed by iron is called as electromagnet. Absolute, beta. So if the core of a ferromagnetic material such as soft iron is placed inside a solenoid, the magnetic field strength inside the solenoid is generally increased because of permeability of the iron. The field lines within the solenoid crowd into the iron core. This has two effects. First, the crowding concentrates the field lines due to the solenoid. The closer together the field lines, stronger is the field. We already know that if we will take the core inside the core, all the lines will exactly crowd inside the core, crowd inside this wire. All the field lines which is around the solenoid will be there. It will crowd inside the core. Okay, with this crowding inside the core, the magnetic effect of this core will increase. Okay, next is second, the field lines along from the solenoid induce a magnetic inside the iron core, so that ferromagnetic material become a magnet. So you know iron is called as ferromagnetic material. Why it is called as ferromagnetic material? Because it has a capacity to, or it has influence of magnetic field. Means influence means it can get attracted towards magnet. Okay, so they are exactly called as ferromagnetic material. So iron, soft iron, first to soft iron is exactly ferromagnetic. It will allow that magnetism to affect it. Okay, so it will be a ferromagnetic. Understood? Everyone understood? So beta, it will act as a ferromagnet. So second, the field line from the solenoid induce a magnetism inside the iron core, so that ferromagnetic material, that is iron, become a magnet whose field supplement the field of the solenoid. So electromagnet are widely used as component of electrical devices such as motor, generator, electric bell. So where you can see electromagnet, where you can see in electromagnet in your day-to-day life. Can anybody tell me? Now only I read where we can see electromagnet in our day-to-day life. Where we can see electromagnet? Yes, beta, that is motor, bells and all these things, electromagnet is there. So they have exactly explained two important things about electromagnet. First important thing, they said that ki crowding, the concentration, again and again I kept on telling about this line, that ki inside the loop the magnetic field strength will be more, means inside magnetic strength will be more. So if all the coiling will be there, then inside a strong magnetic field will be generated. So inside that strong magnetic field, if I will take this iron core, so what will happen? All the magnetic content will go inside and it will exactly make it as a magnet. It will make it as a magnet, but only for time being beta it will act as a magnet. The moment you will stop the supply of current, it will again become a temporary iron core. It will again become a temporary iron core. It will not have any effect of it. It will not have any other effect. I hope you might have understood this point. Now we are going to go towards another important point. Before that point, I need to discuss one more thing. Before that point, I need to discuss one more thing. Now tell me this, can you see? You see here beta, there are two type of coiling. Okay, one coiling is this one. When you take a soft iron core and around it you will coil. Okay, and another one is when you take a U-shaped iron core and around you will coil. You see the insulated wire, how nicely it has coiled. Then tell me which one will be more stronger, which one will have more stronger magnet, which one will be a more stronger magnet, this one or this one? Straight one or U-shaped? Straight one or U-shaped? No Kamya. Kamya, here na, I'll be explaining it beta. I'll be explaining this part Kamya. As Kamya, I'm going to explain this part very nicely beta. First you answer my this question. Which one will have a strong magnet? Which one will be strong magnet? A straight core or a U-shaped core? And around it solenoids are exactly turned. Now which one? Very good. As Kamya is telling you, Keshika is also telling you. Let's see how many of you are feeling that U is the more stronger one. U is the more stronger one. How many of you are feeling U is the more stronger one? Very good. Kavya is also telling it is U-shaped. Very good Kavya. Keshika is also telling U-shaped. Any other person who wants to say U-shaped is more? The correct answer is yes, U-shaped will be more stronger. The reason behind is कि when they will be very near, so one very important work is going on in this. Nashir U-shaped is, Renu U-shaped, Mustafa U-shaped, everyone is telling U-shaped. Yes, so beta the thing here is if we reduce the length of air gap between the pole of electromagnet, then its strength increases. Beta reduce the length of air gap. So here air gap is more. Here in the straight one na beta, air gap is more. Air gap more means you see one side will be acting as north pole and another side will be acting as south pole. So here the air gap, you see the current, the flow of lines will be like this. So air gap is exactly here what? Here length of air gap is more, but here if you will take a U-shaped one, then the magnetic lines from one will act as a south pole, another will act as a north pole. So length of air gap is less. So which one will be more stronger magnet? So the one which is having less air gap. So one is a straight, so air gap is more, lines of force have to travel this much. Here lines have to, force do not have to travel. So here length of air gap is less. So this one is more stronger than the straight bar magnet, straight iron core. Understood? Understood this point beta? Understood? So length of air gap, remember this word, length of air gap between its pole. I am writing here so that you will remember this part. Length of air gap between the poles. Between the poles. Length of air gap between the poles. So wherever length of air gap between the poles will be less, it will be strong magnet. Okay, so here length of air gap is less, so this is a more stronger magnet than this one. This is a more stronger magnet than this one. I hope you might have understood this point beta. So till now our entire concept is rotating around three things. First thing is coiling, second thing is amount of current, third is core material. Today's topic, our entire content is moving in three important points. First important point, number of turns. Second, amount of current flowing in this coil. Third is core material. And core material what we have taken? Iron, soft iron rod. And length of air gap is less in U-shaped. Always the first point you should hit is length of air gap between the poles. length of air gap between the poles. Length of air gap between the poles. Just you remember this point and then you write the statement in your own words. Soft iron, very good. So soft iron, length of air gap between the poles, steel will become magnet. Then we have understood S or N shape. So I hope till here we have understood. Now electromagnetism, in electromagnetic content, what are the difference between? This is one of a question, again and again it is coming. So you have to understand that which one is a permanent magnet. So electromagnets are not permanent magnet. Simple point, we can write in our own words. Till now whatever we have understood, based on that we are just going to summarize things. Bar magnet, permanent magnet. Electromagnet, temporary magnet. This you itself said. I think S. Kamya has used this word, temporary magnet. So bar magnet, permanent magnet. This one is temporary magnet. It is exactly having a weak electric field. It is generating, weak magnetic field. It is having a weak magnetic field. It is having a stronger magnetic field. Okay, the strength of magnetic field cannot be changed here. But here strength of magnetic field can be changed. So polarity is permanent. But here polarity we can change. Polarity is permanent here, we can change the polarity here. What does polarity is permanent? Polarity permanent and polarity change here means what? Just understand this. Ki polarity permanent means here north pole will always be north pole, south pole will always be south pole. But here the coil polarity changes. How polarity changes? If you will allow current to flow through it in clockwise direction. If current will flow in clockwise direction, then it will generate south pole. But if the current will flow in anti-clockwise direction, then it will generate north pole. So its polarity can change, means north pole and south pole can change. But bar magnet, north pole and south pole can never change. Bar magnet, north pole and south pole can never change. I hope you might have understood this point. Come on, quickly tell me. Did you understood this one, beta, polarity and this one? Yes, Abhinami, clockwise south pole, beta. I hope my children might have understood this point today. This PDF is going to go to you today itself. This PDF I am going to send you now only, otherwise again I will forget. So understood or not? So bar magnet, permanent magnet, electromagnet, temporary magnet. One word key point we will remember and we will write in our own word. Permanent, temporary. Weak force of attraction, stronger force of attraction. Strength, permanent, its strength can change. Here polarity fixed, polarity can change. Polarity fixed, polarity can change. So if any content will come, I think you will be able to answer. So which one is a permanent magnet? Then you will say that bar magnet is a permanent magnet. Which one is a temporary magnet? Electromagnet is a temporary magnet. Then they will ask why? Why electromagnet or temporary magnet? Because you can change the strength of this magnet, and once the current supply will stop, the iron core, soft iron core will no longer be magnetic. It will lose all its magnetic effect. It will again become a soft iron core. Okay? It will again become a soft iron core. I hope till here I am not going to extend and comprehend everything, just simple part. So today whatever important point I have given, did you understood everything from the beginning till the last? All the points, beta, all the points you have understood, like any point which was creating problem for you. So one point I think everyone is having problem, and that is that auntie, you told always that in the poles the magnetic field strength is more, but auntie, when you are talking about solenoid, you are talking that inside magnetic field is very strong. Inside magnetic field is very strong. This is the confusion I know my children are having. Yes, I am going to start, beta. So that question will be, beta, the answer will be yes, in poles the magnetic lines will be strong, inside also and outside poles also it will be strong. Okay, but Tanishka understood na, beta? God bless you all. So I am going to start 11th class now. Bye everyone. Bye everyone.